This is a hands-on class, so open the lab guide and build a pipeline alongside me. Last class you learned Git and 8 how to track changes and collaborate on code. Now we answer the natural next question. Once your code is in Git, how does it actually get built, tested, and shipped to your users? For a long time, the answer was N8220 by hand, N8221, and it was painful. Someone would manually build the software, manually run some tests if they remembered to, and manually copy it onto the servers, and 200, a slow, tense, error-prone ritual that everyone dreaded, often done late at night and frequently going wrong. Release day was a scary event. CICD is the modern answer that makes all of that stress disappear. CICD stands for continuous integration and continuous delivery, and A212, or deployment and A212, and it means building an automated pipeline that takes every change from your code repository and automatically builds it, tests it, and delivers it toward production. The same way every single time. Instead of a risky manual scramble, you get a reliable machine that ships your code. Teams that do this well release many times a day, safely, with confidence, because the path to production is automated and trustworthy. Today, you will learn what continuous integration is, how a pipeline works, why automated tests are the heart of it, the difference between delivery and deployment, and why fast feedback changes everything. Let us automate the path to production. Here is what we will build today. First, why CICD matters. Second, continuous integration. Third, the pipeline. Fourth, automated tests. Fifth, delivery versus deployment. And sixth, fast feedback. Let us begin. Let us start with the pain that CICD removes. Because once you have felt it, the value is obvious. Doing the release process by hand is a nightmare in slow motion. A person has to remember to build the software correctly, remember to run the tests, remember every step of copying files and restarting services on the production servers and A200 call, and do all of it without making a mistake. It is slow because a human is doing tedious work step by step. It is inconsistent because different people do it slightly differently, and even the same person forgets a step under pressure. And it is scary because a single missed step can take down production. Manual releases are where outages are born. CICD replaces that with an automated pipeline and AT200, or defined automatic sequence that takes every change and runs it through the exact same steps, the exact same way, every time. The computer builds it, the computer tests it, the computer deploys it, following a script that never forgets a step and never gets tired or rushed. What was a tense manual ritual becomes a reliable, repeatable machine. The same change, run through the same pipeline, produces the same result, and 82 on 12. That consistency is the whole point. And the payoff is transformative. Because the path to production is automated and reliable, releasing becomes fast and A212. No waiting for a person to work through steps and A212. And safe, because the same tested process runs every time and catches problems automatically. This is what lets modern teams ship many times a day instead of once a month, with far fewer incidents. Releasing stops being a dreaded event and becomes a routine, almost boring non-event, which is exactly what you want. Boring releases mean reliable software. The goal of CICD is to make shipping code so automated and trustworthy that it fades into the background. That frees your team to focus on building, not on the terror of deploying. So the takeaway, releasing software by hand is slow, inconsistent, and scary, and 81, a source of outages, and 200. So CICD replaces it with an automated pipeline that builds, tests, and deploys every change the same way, every time, making releases fast, safe, and routine enough that teams can ship many times a day with confidence. Let us take the two halves in turn, starting with the CI and A200 fall, continuous integration. It is about how a team and code changes come together. The core practice is that everyone integrates their work frequently and A202, merging the small changes into the shared main branch often, many times a day. Rather than each person working in isolation for weeks and then attempting one giant, painful merge at the end. Recall from the Git class how branches and merging work. Continuous integration is the discipline of merging back early and often, in small pieces, so the shared codebase is always up to date with everyone. N39S work. Small, frequent merges instead of rare, huge ones. And here is the ANI A2 fine. Continuous in A2 fine 201, path that makes it powerful. Every time someone integrates a change, an automated build and test run is triggered immediately. The moment a change lands in the shared branch, the system automatically compiles the code and runs the test suite against it, checking that the new change works and, crucially, that it did not break anything that was already there. This happens automatically, within minutes, on every single integration. Nobody has to remember to check. The system checks every time. The benefit of this is enormous and specific. Problems are caught immediately when they are small and easy to fix. If your change breaks something, you find out within minutes of making it, while the change is tiny and fresh in your mind, and A212, not weeks later, buried under a mountain of other changes, when finding the cause is a nightmare. Because everyone integrates small changes constantly, and each is verified instantly, the shared codebase stays healthy and integration stops being a dreaded NP230, Big Bang in A220 event. This is why it is called continuous integration. You are continuously keeping everyone and 39's work merged and verified, rather than letting it drift apart and colliding painfully at the end. It is the foundation the rest of the pipeline builds on. So the takeaway, continuous integration is the practice of everyone merging small changes into the shared main branch frequently, with each merge automatically triggering a build and the full test suite and A200-202 so that a broken change is caught within minutes while it is small and fresh, keeping the shared codebase healthy and avoiding painful Big Bang merges. The engine that runs all of this is the pipeline, and picturing it clearly makes everything else fall into place. A CICD pipeline is an automatic sequence of stages that a change passes through on its way to production in A2012. Think of it as an assembly line for your code. A typical pipeline has stages like build the code, run the tests, deliver the tested build to a staging area, and finally, deploy it to production. Each stage is an automated step that does one job in the journey from a raw code change to running software. The change enters at one end and, if all goes well, comes out the other end live in production. The crucial rule of the pipeline is that a change only advances to the next stage if the current stage succeeds. The code must build successfully before it can be tested. It must pass all its tests before it can be delivered. It must be delivered before it can be deployed. Each stage is a gate, pass, and you proceed, fail, and you stop right there. This means a broken change cannot slip through to production and A212. It gets caught at whichever gate it fails, and the pipeline halts and reports the problem. The assembly line refuses to pass along a defective product. This staged, gated design is what makes the pipeline both automatic and safe. It is automatic because each stage triggers the next with no human intervention when things pass. It is safe because the gates ensure that only changes which have successfully built and passed every test make it further down the line. You define this pipeline once, and AT2BOF, the stages and the order, and AT2BOF usually as a configuration file that lives alongside your code, and then it runs automatically for every change forever after. In today's NF39S lab, you will define a simple pipeline and watch a change flow through its stages. Understanding the pipeline as a gated assembly line and 88112. Build, test, deliver, deploy, each stage a checkpoint, and 88112 is the mental model that makes all of CICD concrete. So the takeaway, a CICD pipeline is an automatic assembly line of stages and 8212, build, test, deliver, deploy, and 8212, where each stage is a gate that a change must pass to advance to the next. This staged, Gated design makes shipping both automatic, since passing stages trigger the next, and safe, since a broken change is stopped at the gate it fails. At the very heart of the pipeline sits the stage that makes the whole thing trustworthy: automated testing. Without it, a pipeline just ships bugs faster. Automated tests are checks written as code that verify your software behaves correctly and 8212, and the pipeline runs them automatically on every single change, with no one needing to remember. This is the test stage, and it is the pipeline in T9 safety net. Every time a change comes through, the full suite of tests runs against it, exercising the software and confirming that it still does what it should. Because it is automatic and runs every time, nothing gets shipped without being tested, and 812112, a discipline that is almost impossible to maintain by hand. The outcome of the test stage decides the change in 39 safe fate. If all the tests pass, the change is verified and allowed to advance down the pipeline toward production. If any test fails, the pipeline stops immediately, and 8002 how the change does not proceed, and 8002 how, and it alerts the team that something is broken. This is the gate doing its job. A change that breaks the software is caught right here at the test stage and prevented from ever reaching your users. The safety net catches the fall before it happens. This is why the quality of your automated tests is so important, and A212. The pipeline is only as safe as the tests it runs. Good, thorough tests catch real problems and give you genuine confidence to ship. Weak or missing tests let bugs sail straight through, and then the pipeline is just delivering broken software efficiently. So, investing in a solid test suite is investing in the trustworthiness of your entire release process. The automated test stage is what transforms CICD from NEA 2000 T200 shipping fast and A2000 T200 into NEA 2000 shipping fast and safely, NEA 2000 T2000 and A2000 T200, and that word safely is the whole difference. It is the reason teams can deploy many times a day without fear. They trust the tests to catch what humans would miss. Build your tests well, and the pipeline protects you. Neglect them, and it cannot. So the takeaway? Automated tests are code-based checks the pipeline runs on every change as its safety net, and A212. If they all pass, the change advances. If any fails, the pipeline stops and alerts, and 8012. So broken change never reaches users. And because the pipeline is only as safe as its test, investing in a thorough test suite is what turns shipping fast into shipping fast and safely. Now, let us clear up the two meanings hiding in the N-Actutua, CD and Atua of CICD, because they are related but importantly different. Continuous delivery and continuous deployment. Continuous delivery means that every change which passes through the pipeline and 812 built and fully tested and 812 is automatically prepared and kept ready to deploy to production at any moment. The software is always in a releasable state, sitting one step away from live. But that final step, NA2112P, the actual push to production NA2112, is triggered by a human with a click of a button when the team decides the moment is right. The pipeline does everything up to the doorstep of production automatically. A person opens the door. This gives you speed with a moment of human control over exactly when things go live. Continuous deployment goes one step further and removes even that human click. With continuous deployment, every change that passes all the automated stages is deployed to production automatically with no human intervention at all. Pass the tests, and you are live, and 8212, immediately, hands off. This is the fullest expression of automation. Code merged in the morning can be serving users minutes later, entirely without a person in the loop, because the team trusts the pipeline and its tests completely to gate what ships. So the distinction is simply about that last mile. Continuous delivery, automatically ready to release, a human decides when to click. Continuous deployment, automatically released, no human step at all. Both share the same automated build and test pipeline. They differ only in whether a person presses the final button. Which one a team chooses depends on their confidence and their context, and 8 hopeful. Deployment demands rock-solid tests and a high tolerance for full automation, while delivery keeps a human checkpoint for that final go-live decision. Many teams run continuous delivery and reserve fully automatic deployment for the parts they trust most. Either way, the hard work and A200 wall, the automated tested path to a releasable build, and A200 is the same, and it is the real price. The final button is a detail of how much you automate the very last step. So the takeaway, both meanings of CD share the automated build and test pipeline and differ only in the last mile, and A2112. Continuous delivery keeps every passing change ready to release at a human NTRC click, while continuous deployment pushes every passing change live automatically with no human step. Which you choose depends on your confidence and context, but the tested path to a releasable build is the shared price. Underlying everything we have discussed is a principle that is the real reason CICD works so well. Fast feedback. It is worth naming directly because it changes how it feels to build software. The whole pipeline is a feedback machine. When you make a change and push it, the pipeline runs an A212, building, testing, and A212, and it tells you quickly whether your change is good or broken. Within minutes of pushing, you get a clear signal, green, everything passed, and your change is on its way, or red, something failed, and here is what. That rapid verdict on every change is the core service the pipeline provides. And getting that verdict fast, rather than slowly, makes an enormous difference to the cost of a mistake. If a bug is caught within minutes of you writing it, the fix is easy, the change is small, you remember exactly what you did, and the context is fresh in your mind. But if the same bug is only discovered days or weeks later, an A212, buried under many other changes, long forgotten, an A212, tracking it down becomes slow, confusing, and expensive, and it may have already caused damage in production. The longer feedback takes, the more a small mistake festers into a big, costly problem. Fast feedback catches problems while they are cheap. This is why speed matters so much for a pipeline, and why ND 200, fail fast in 8200, is a virtue, not a failure. A pipeline that quickly and loudly stops a broken change is doing you a favor, and A212. It is saving you from that change reaching production and from having to debug it later blind. The faster your pipeline runs, and the sooner it fails on a bad change, the tighter your feedback loop, and the more confidently and quickly you can build. It also means you should keep your pipeline fast. A slow pipeline that takes an hour delays the feedback and tempts people to bypass it, which defeats the purpose. Fast feedback, delivered by a fast, reliable pipeline, is ultimately what makes CICD feel like a superpower. And A200 dual. You change something, and you know within minutes if it is safe. That certainty on every change is what lets teams move fast without breaking things. So the takeaway, the deep value of CICD is fast feedback and A212. The pipeline tells you within minutes whether every change is good or broken, and catching a bug while it is small and fresh makes it cheap to fix. Whereas discovering it days later is slow and costly. So an A2, failing fast and A2 is a virtue. And keeping the pipeline fast is what makes the whole thing a superpower. Let us watch a single change travel the whole pipeline, so all the pieces connect into one motion. You finish a small change and push it to the shared repository. That push is the trigger. The CI/CD pipeline springs to life automatically. First, the build stage compiles your change together with the rest of the code, confirming it all fits together and produces a working artifact. If the build fails, you are told within moments, and the pipeline stops. If it succeeds, the change advances to the next gate. So far, everything is automatic, and you have done nothing but push. Next comes the test stage, the safety net. The full automated test suite runs against your change, exercising the software to confirm it still behaves correctly and nothing is broken. Pass, and the change proceeds. Fail, and the pipeline halts and alerts you, having caught the problem before it could reach anyone. Assuming it passes, The change moves on to be delivered, and 8212112 packaged and placed in a staging area, fully built and tested, ready for production. Each stage has automatically handed off to the next, with the gates ensuring only a healthy change gets this far. Finally comes going live. Under continuous delivery, the change now waits, ready for a human to click and it hudaswa, release and it hudaswa. At the chosen moment, under continuous deployment, it deploys to production automatically and it is live. Either way, minutes after you pushed a small change, it has been built, tested, and taken safely toward or into production entirely by the pipeline. That is the whole of CICD in one motion: push, build, test, deliver, deploy, and 8-200 automatic, gated, and fast for every change every time. In today in T9 S-Lab you will set up exactly this flow and watch your own change, ride the pipeline from a commit to a running result. Seeing it happen is what makes the power of it real. So the takeaway, a single change flows through the whole pipeline in one automatic motion, and A212. Your push triggers a build, then the tests, then delivery to staging, then going live either at a click or automatically, and A212. So minutes after pushing, a small change is built, tested, and safely deployed by the pipeline, gated at every stage for every change every time. Let us close with the habits that make CICD genuinely effective, because the tooling only pays off with the right practices around it. First, commit small and merge often. The whole benefit of continuous integration depends on changes being small and frequent. Small changes are easy to build, quick to test, and simple to fix when something breaks and 80 or told. And they keep everyone in S work merge so integration never becomes a painful big bang event. If you let changes pile up into huge infrequent merges, you lose the fast, safe feedback that makes CICD work. Small and often is the rhythm the whole system is designed around. Second, invest in your automated tests, because the pipeline is only as safe as they are. A pipeline with weak tests just shifts bugs efficiently. A pipeline with strong, thorough tests genuinely protects your production. So treat your test suite as first-class work. Write tests for the important behavior and keep them reliable and 82.5. Flaky tests that fail randomly erode trust until people start ignoring the pipeline, which is fatal. Good tests are what let you deploy with confidence, so they are worth the effort. And third, keep the pipeline fast. Fast feedback is the core value, so protect it. A pipeline that takes an hour delays every verdict and tempts people to skip it, or batch changes, both of which defeat the purpose. Aim for a pipeline that runs in minutes, so the loop stays tight and the tool stays trusted and used. Commit small, test well, and keep it fast and 8-2 Those three habits turn CI/CD from a piece of infrastructure into a genuine change in how safely and quickly your team can ship. Automate the path to production, look after these habits, and releasing becomes something you do many times a day without a second thought. So the takeaway, make CI/CD effective with three habits and 8-12. Commit small and merge often so integration stays cheap and feedback fast. Invest in a strong, reliable test suite, since the pipeline is only as safe as its tests. And keep the pipeline fast, so the feedback loop stays tight and people actually use it. And A202 call, turning CI/CD into a real change in how quickly and safely you ship. Let us gather the whole class in one breath. CI/CD replaces slow, risky manual releases with one automated, reliable path to production. Continuous integration means merging small changes often, with each automatically built and tested. The pipeline is a gated assembly line, and A212. Build, test, deliver, deploy, and A212, where a change advances only if the stage passes. Automated tests are the safety net that catches a broken change before it ever ships. Continuous delivery keeps changes ready at a click. Continuous deployment takes every passing change live automatically. And fast feedback catches problems in minutes, while they are small and cheap to fix. Next class, and 8-2012, containers and Docker, packaging your app to run anywhere, one idea at a time. That is CI